Okay, that's the heading of our next topic. Fine. So, when factors affecting corrosion is to be discussed, okay, then it can be categorized into two types. One is the nature of the metal and the nature of the corroding environment. Now, just you should all excuse me for today. Um, there's a handwritten copy, and I shall be showing that to you all. Okay, and just write the classification. Ardhamautundi kada? I should turn the screen. Okay, please make yourself free to ask me or pause me whenever you feel uh, uncomfortable handling it. But right now, I'll turn the screen and I'll be explaining about the factors affecting corrosion. Okay, turn the screen, and the heading is, what's the heading? Factors affecting corrosion. Okay, CR, good morning. Neeraj,
Good morning, ma'am.
is the screen clear
Yes, ma'am. Somewhat blurred, ma'am.
now?
Okay, ma'am. It's clear, ma'am.
Now, what's the heading? Factors affecting corrosion. Factors affecting corrosion. Okay, then in that, the first point is the rate of corrosion depends upon the following factors.
Ma'am?
Huh? It's
Ma'am?
not clear?
Otherwise, send in Google Classroom, ma'am. It's better, ma'am. Because
How many I can take? I'll be talking point after point. Okay.
okay, ma'am. Okay, ma'am.
Okay, let me write it for you all. The rate of corrosion depends on the following factors. What are those two? Nature of the metal, nature of the corroding medium. Okay, so what's the first point? The rate of corrosion depends upon the nature of the metal and the nature of the corroding environment. Nature of the metal and nature of the corroding environment dictates the rate of corrosion. Nature of the metal, nature of the corroding environment. Okay? Easy. Now, if you can understand this easily, nothing like that. Okay? All these are your 2 marks questions in your final exam. Okay? So, ఏం చెప్పాను, కరోషన్ ని స్టడీ చేస్తున్నాను. సో ఇదంతా వెట్ కరోషన్ ని డ్రై కరోషన్ అంతా అర్థం చేసుకున్న తర్వాత నేను ఒక కంక్లూషన్ కి రావాలి కదా. అంటే ఏంటి, ఏవి కరోషన్ ని ప్రమోట్ చేస్తే ఏవి కరోషన్ ని ప్రమోట్ చేయవు. అంటే ఏది ఎలా అయితే కరోషన్ మినిమైజ్డ్ గా ఉంటుంది, ఎలా అయితే కరోషన్ ఎక్కువ అవుతుంది అని ఎలా తెలుస్తుంది అంటే ఏది చదువుకుంటే తెలుస్తుంది, ఫ్యాక్టర్స్ అఫెక్టింగ్ కరోషన్. So the rate of corrosion depends on the following factors. Entity, nature of the metal, nature of the corroding environment. So these two are the factors that mainly dictate the rate of corrosion. Okay. Now that's the first point. Now what's the second point? Now I want to focus on nature of the metal. Okay. So that's the second point, right? Nature of the metal. See, everyone here in the session, please remember that when you're talking about the nature of the metal, there are many factors, out of which I've just identified what are there in your syllabus, which are commonly asked in your exam, and I have given this. Okay, but if you peep into textbook, you'll find many more. So I have avoided all those. So I took only these 6. Okay. So under nature of metal, what are the 6 possibilities? Okay. The first one is position in galvanic series, right? Position in galvanic series. Position in galvanic series. The second factor is relative areas of anodic and cathodic parts. Relative areas of the anodic and cathodic parts. Relative areas of the anodic and cathodic parts. Okay. The third one is purity of the metal. Purity of the metal. Now, fourth one is physical state of the metal. Fourth one is physical state of the metal. Fifth one is nature of surface film. Nature of the surface film. The sixth one is solubility of corrosion products. Sixth one is solubility of corrosion products. I hope every one of you have written. So what is the first one? Position in the galvanic series. Second one is relative areas of anodic and cathodic parts. Third one is purity of the metal. Fourth one is physical state of the metal. Fifth one is nature of surface film. Sixth one is solubility of corrosion products. Okay. Now, that's the first classification. Okay. That's about the nature of the metal. Did every one of you write? Now, please raise your hand by chance you didn't write this. Okay. I hope every one of you have written. Okay. Now write the second one or the third one. Second factor. Nature of corroding medium. Corroding medium. I think the spelling here is wrong. The nature of the corroding medium. Corroding, D-I-N-G. Nature of the corroding medium. Is the spelling correct? Nature of the corroding medium or environment. Under that you have, just check. Under that you have the first one is temperature. First one is temperature. Please kids, don't take leisure on this. This flowchart has to be present with you. Do write it. Don't think that you have notes on hand. This is important. Okay, temperature. Next, humidity of air. Humidity of air. Next, influence of pH. Influence of pH. Influence of pH. Next. The next one is presence of impurities in atmosphere or suspended particles. Please write this. Presence of impurities in atmosphere or suspended particles. Next one is nature of ions present. Nature of ions present. Next, conductance of the corrodic medium. Please check. Conductance of the corroding medium. Conductance of the corroding medium. Next, the last one is formation of oxygen concentration cell. Formation of oxygen concentration cell. Okay. Very important, generally asked for 2 marks questions, in which the temperature, humidity, pH, and the concentration cell are most fond after topics they are commonly asking every time. Okay. So let me revise again. The second factor that affects corrosion is nature of the corroding environment. When the nature of the corroding environment is discussed, I'll talk about the temperature, okay, humidity of air, influence of pH, presence of impurities in atmosphere or suspended particles, nature of ions present, conductance of the corroding medium, and formation of oxygen concentration cell. So these are the things which I am discussing today. Very easy. Only thing is you need to understand. For that, I'll make it more interactive. Okay. But what is the pick? Okay. I'm talking about the factors affecting corrosion. The rate of corrosion depends upon the following factors. The first one is nature of metal. The second one is nature of the corroding environment or the medium. So I'll begin with the first one, nature of the metal. In that, position in the galvanic series, relative areas of anodic and cathodic parts, purity of metals, physical state of the metals, nature of the surface film, and solubility of corrosion products are the major points that would be discussed. Okay. So the first point is nature of the position of the metal in galvanic series. So the first one is position of metals in galvanic series. Position of metals in galvanic series. Now, roll number 120. Absent. 19. Roll number 19.
Yes, ma'am.
119.
Voice is
180.
breaking, ma'am.
వాయిస్ బ్రేక్ అవుతుందా?
ఇక్కడ నెట్ ప్రాబ్లం ఉంది, మ్యామ్.
నీ దగ్గర నెట్ ప్రాబ్లమా?
ఎస్ మ్యామ్.
ఓకే, సరే చెప్పు. నీరజ్.
ఎస్ మ్యామ్.
When two different metals are combined together, which metal will act as anode and which metal acts as cathode?
Metal which has a less SRP value acts as anode, ma'am. Takes place corrosion, ma'am. Which has more SRP value acts as cathode. There will be no corrosion, ma'am.
Okay. Sare. Then the next question is, instead of pure metal, I've taken alloy. Steel is an alloy of. Chappu.
Ma'am?
Steel is an alloy of.
That carbon.
Iron, carbon, nickel, chromium, etc. Okay.
Yes, ma'am.
Now, if you have steel structures for construction, okay. Now, how will you say it will suffer less corrosion than pure iron? How to know?
Ma'am, repeat once again, ma'am.
Say, instead of iron, okay, you have used steel. Okay, fine.
Okay,
Now
ma'am.
you want to tell that the iron will undergo faster corrosion than steel. How will you tell? Both are metals, and in both the cases there is iron present. Okay, but it's a common general experience for that, for us, that when you take iron and steel, out of these two, which suffers more corrosion? Tell me.
Iron, ma'am.
Iron. Steel suffers quick corrosion or not?
No, ma'am.
No. Why? Why? What is
Means
your guess?
it directly reacts with.
Okay. Roll number 118 has left because he's scared answering. Okay. Now 117 is present.
Ma'am, that iron is fastly reacting with oxygen, na, ma'am.
ఎందుకో సరే, అసలు అలా అనుకుంటే ఎందుకు ఐరన్ ఎలాయ్స్ చేయాలి? ఐరన్ ఎందుకు ప్రొటెక్ట్ చేయాలి?
Don't know.
చెప్తున్నా విను. ఓకే, నెక్స్ట్ రోల్ నెంబర్ 116. 115. Why Shaker? Why you have left? It's nothing to worry. It's all general discussion. Okay. Next, 15. 115. 115. 114. 113. 12. 11. And ante, what you indirectly convey is that don't ask us questions, which is nonsense. What is the necessity to make an alloy? First instance, why we should make alloys? You tell me. Why alloying of metals is done? To improve
decrease
its.
corrosion.
ఎందుకు నాన్న? Not
To
yeah.
decrease
Main is corrosion.
Yes, ma'am.
Main corrosion. కానీ for that example, iron ఉందనుకో, pure iron is actually an industrial material? No. ఎందుకు? Because it is not very hard. It's not a tough material at all. It is made very, very strong due to doping of carbon. Okay. The carbon that is added to iron metal, pure iron metal, makes it a strong material. But that alone is not sufficient. Most of the machinery use iron in that format. But for all practical purposes, we do alloying of iron to improve its physical, chemical, and mechanical properties. Okay. The physical property could be the corrosion resistance. Okay. Next one is its malleability, probably its ductility. Okay, and its metallic properties are all the physical properties that are generally studied. The chemical reactivity. Obviously, the alloyed metal will have a blend of properties. Okay, and of course, its reactivity is also completely changed. And how about the mechanical properties? The stress and strain. We know that the huge construction industry is all about the main pillars, which contain iron as a base material, and hence is the strength of the materials. So that's what they study. The civil and mechanical engineering people study about the strength of these materials. Okay, so under those heavy loads, the metro train is going on those pillars, and the pillars are constructed along with the concrete. They put the major, huge, fat iron bars. You can just see in the metro train construction, the material of strength out there. Okay, so is the discussion, but we should always be conscious or aware of using a particular material for a particular application. I already told with you all that copper is the material which has highest conductance. Okay, but still can't be used for power transmission lines because of its corrosion properties. Okay, because it suffers faster corrosion as compared to aluminium, which suffers less corrosion and shows a property called as passivity. Now, why that passivity? We have already discussed that the oxide film that is formed on the aluminium, Al2O3, will be taking a small sheet-like structure, protecting the base metal from undergoing further corrosion. So, aluminium may not be very excellent metal actually, but because of its property of passivity, it is actually used very exclusively for engineering applications. So is nickel, chromium. The oxide films that are formed on these metals will not allow faster corrosion to take place, making those metals very, very noble. They are not just like gold, platinum, palladium, or silver, that the oxide film formed is unstable and the pure metal remains like that. But what will happen? The chromium oxide or the nickel oxides that are formed will form a thin sheet on the base metal and will stop corrosion because the oxide film is stable and non-porous, rendering that metal a property of passivity. So what is passivity? The inertness towards the corrosion, which is exhibited by metal, is nothing but passivity. Okay, and hence is very interesting. That's the reason why we are alloying iron with chromium or nickel, etc., to improve its corrosion inhibition properties, and hence are just very widely used for different applications. We know that. Okay, so that's the one point. Now we have understood that the metals or alloys having less SRP value will act as anode and will suffer corrosion. But in the EMF series, there is no discussion about alloys. It's only about metals and okay. A perfect disaster today. Okay, which have to survive. So I have to talk about a series called as Galvanic Series. I have to talk about a series called as Galvanic Series, which talk about the corrosive behaviors of various metals and their alloys. Okay, ఏం చెప్తున్నా అర్థమైంది కదా? Corrosion అంటే oxidation process, reduction process. Roll number 68. 68 is present. 78.
Yes, ma'am.
Roll number 68. Good morning. Good
Good morning,
morning. Yeah. చెప్పు నాన్న. EMF series లో
Good morning, ma'am.
ఏముంటుంది? You know about EMF series?
No, ma'am.
Okay. Why? I have explained umpteen number of times in electrochemistry chapter. You should have studied that. No problem. Okay. Now better you take what it means by galvanic series, right? Galvanic series. It is a series. It is a series in which various metals and alloys. It is a series in which various metals and alloys are placed in the decreasing order of their corrosion potentials. Various metals or alloys are placed in the decreasing order of their corrosion potentials. Okay. So,
Ma'am, repeat once again, ma'am. Repeat once again. ma'am.
Shivaji, చెప్పు నాన్న. Corrosion is an oxidation process or a reduction process?
Corrosion, ma'am. Reduction
Corrosion,
process, ma'am.
oxidation process or reduction process?
Reduction process, ma'am.
ఏంటి నాన్న, అస్సలు నువ్వు వినట్లేదా? నేను సరిగా చెప్పట్లేదా? క్లాస్ చెప్పు నాకు నువ్వు ఫస్ట్.
నేనే సరిగ్గా ఉంటాను.
ఎందుకు నాన్న, ఎందుకు వినట్లేదు? నువ్వు కూడా కరోడ్ అయిపోదాం అనుకుంటున్నావా? చక్కగా ప్యూర్ మెటల్, ఇప్పుడు చక్కగా ఫస్ట్ ఇయర్ లో ఉన్నావు, హ్యాపీగా ఉన్నావు, ఎంతో క్లాసెస్, రెడీ అవ్వాల్సిన పని కూడా లేదు. ఏమైంది ఏమ్మా? సరే అయితే నువ్వు కూడా పాట పాడు. పాడు. ఏ పాట పాడుతావు?
రావు, పాటలు రావు.
మరి ఏమొచ్చు? ఏమొచ్చు చెప్పు నీకు. సరే, 78 అమ్మాయి శృతి భయపడి పారిపోయింది. ఉన్నావా 78 రోల్ నెంబర్? 88 roll number 88 is present. 98, 108. 108 should tell. They are always rescue teams. Roll number 108 is present.
No, ma'am.
Good morning. చెప్పు నాన్న. Corrosion is an oxidation process or reduction process? Pradeep. Who in the class can answer this question? Corrosion oxidation process or reduction process?
Oxidation.
Oxidation process, ma'am.
Oxidation process. Loss of electrons or gain of electrons?
Loss of electrons.
Loss of electrons.
సో నేను ఒక చిన్న మాట చెప్తాను. ఎవరైతే ఆన్సర్ చేయలేకపోయారో, దిస్ నథింగ్ టు ఫీల్ సారీ అబౌట్ ఇట్, బట్ యూ షుడ్ లెర్న్ ఇట్. ఓకే. సో ఆక్సిడేషన్ ప్రాసెస్ నేనేం చెప్తున్నాను? గాల్వానిక్ సిరీస్ లో metals and alloys are placed in the decreasing order of their corrosion potentials. అంటే decreasing order of their oxidation potential అనే కదా, అంతేనా? అంటే గాల్వానిక్ సిరీస్ లో టాప్ టు బాటమ్ నువ్వు వెళ్ళావనుకో ఏమవుతుంది? కరోషన్ తగ్గిపోతుంది. ఓకే. సో ద ఆక్సిడేషన్ ఆర్ కరోషన్ పొటెన్షియల్స్ ఆర్ డిక్రీసింగ్. అంటే ఇండైరెక్ట్ మీనింగ్ ఏంటి? రిడక్షన్ పొటెన్షియల్ ఇంక్రీజ్ అవుతుంది, కానీ అలా చెప్పాం. ఇది ఇలా ఎక్స్ప్రెస్ చేస్తాం. సో గాల్వానిక్ సిరీస్ ఇస్ ఎ సిరీస్ ఇన్ విచ్ వేరియస్ మెటల్స్ and their alloys are placed in the increasing or decreasing order of their corrosion potentials. That is the galvanic series. Okay. And what is the difference between galvanic series and EMF series? Please write down. Galvanic series and EMF series. Okay. Galvanic series includes metals and alloys. It will include various metals or alloys. Whereas the EMF series will have metals and non-metals. It will include metals and non-metals. That's the first one. Okay. Next. Here, what you'll say? Oxidation or corrosion potential. Oxidation or corrosion potential decreases from top to bottom. Ante enti? Metal on the top will be corroding faster than the metal at the bottom. So oxidation or corrosion potential decreases from top to bottom. Whereas in this case, the reduction potential increases from top to bottom. Reduction potential, which I'll call it as SRP values under standard conditions, reduction potential increases from top to bottom. Okay, that will be another one. And here, metals or alloys are placed in seawater. Metals or alloys are placed in seawater. So that is the electrolyte is seawater. Whereas in this case, metals or non-metals are placed in their own metal ion solutions. Metals or non-metals, metals or non-metals are placed in their own metal ion solutions. Are placed in their own metal ion solutions. Okay. Next. Here, standard electrode is calomel electrode. Here, standard electrode is calomel. Here, the standard electrode is hydrogen gas electrode. Standard electrode is hydrogen gas electrode. Okay. These are the four major important differences between galvanic series and EMF series. This series gives corrosion potentials and this series gives the reduction potentials. Okay, so we can easily understand. Both series have the same concept. The metal on the top undergoes corrosion than the metal that is present at the bottom. Okay. Here, metal on top acts as anode, metal on the lower position acts as cathode. Ade standard runditlo. Kani ikkada metals alloys తీసుకుంటున్నాం, ఇక్కడ metals and non-metals తీసుకుంటున్నాం. Okay. So position in the galvanic series ante enti? I have taken two different metals, zinc and copper. I know that zinc will act as anode and copper acts as cathode. What we should think that zinc, because it is present on the top, undergoes corrosion, then copper that is present at the bottom. Because the corrosion potential of copper is less than the corrosion potential of zinc. Okay. Or I can say SRP value of iron is minus 0.44 volts and that of zinc is minus 0.76 volts, which acts as anode and which acts as cathode. చెప్పండి. SRP value of iron ఎంత -0.44, zinc ఎంత -0.76. ఏది యానోడ్ ఏది క్యాథోడ్? Hello, none in the class, no? Which will anode act as anode?
Zinc, ma'am.
Huh? Zinc. ఎందుకు?
Less SRP value.
Why suddenly you felt like answering, whereas your friends are snoring? This is about the position of the metal in the galvanic series. Now, what's the next one? What's the next one? Relative anodic areas and cathodic areas. What did I tell you yesterday? That when you're talking about bimetallic corrosion, okay, what should be the best thing? And suppose one example of bimetallic corrosion in the practical world is steel pipes connected with copper plumbing. Steel pipes connected with copper plumbing. అంటే ఏంటి? రెండు ఐరన్ పైప్స్ ని నువ్వు కాపర్ మధ్యలో కప్లింగ్ చేసి కనెక్ట్ చేసావు. ఏమవుతుంది? Which suffers faster corrosion? Copper coupling or iron pipe? Right. All of kids there. Now, if you don't answer this, no problem. I'll take the topic as conclusion. What's your answer? Don't feel shy.
The iron, ma'am.
Huh? Which suffers corrosion?
Iron.
Iron suffers corrosion. ఎందుకు? ఎందుకు? బాబోయ్, చచ్చిపోతున్నా మీతో ఆన్సర్స్ చెప్పించలేక. Hello. Why iron suffers corrosion?
More oxidation potential.
More oxidation potential as compared to
Copper.
copper. Very good. Now, if that is the combination, will the rate of corrosion will be more or less? Is my question. What's your guess?
More, ma'am.
Why? Because the anodic area is very, very high. Once the corrosion kicks off, the rate of corrosion will be very, very high. ఎందుకు? Copper ఎక్కడ మొదలవుతుంది corrosion? At the juncture where the coupling is there. Okay? And because the whole anodic area is there, so the rate of corrosion is very, very high. And then hence we should be very, very careful about the cathodic and anodic corrosion. Like for example, if you are taking, for example, the copper is there and large copper pipes are there and small iron coupling is there. What will happen? Though there will be corrosion, iron will undergo, which is small coupling, will undergo corrosion as compared to the large cathodic copper. In such cases, the rate of corrosion is less. So what you should always remember is that the rate of corrosion is directly proportional to the area of anode and cathode, the relative areas. Okay, large cathodic areas suffer less corrosion as compared to large anodic areas. Common logic. That's it. So when you're coupling two metals, you should always be careful that the cathodic area should be large and anodic area should be small to avoid faster corrosion. Okay, that should be your concept. Okay, so what's the next one? So what do you write under this point? Relative anodic and cathodic areas. Cathodic area should always be larger than the anodic areas for minimizing the rate of corrosion. Now, when you're talking about the purity of metal, what is it is generally told? Pure metals are always preferred over bimetals. Okay, that's the first point. And what here they're talking about the purity of metal is when the metals, if you're watching under microscope, you'll find the granules. Okay, the metals are solidifying in such a way that you know the FCC crystal structure, BCC crystal structure, HCC crystals you have studied in the physics chapter in your first semester. Am I right? Okay. So what you are understanding here that metals undergo solidification or crystallization in a particular pattern. Okay. And upon crystallization, they form what are called as granules. Okay. Between the granules, there exists intergranular corrosion. Okay. So if pure metals are present, the intergranular corrosion is minimum, and hence is the discussion. Okay. Next, what about the physical state of the metal? Okay. First point you need to know here is physical state. Larger granular metals will suffer less corrosion as compared to the smaller granular metals. That's the first point. And metals generally in the solid state suffer less corrosion than the liquid metals, which are susceptible to more corrosion. Okay, and hence is the discussion. Nature of the surface film. Now answer this. When you're talking about the nature of the surface film, what are the four types of oxide films you have? Tell me. What are the four types of oxide films you have? Did I ever told you about the four types of oxide films? Hello? What are the four types of oxide films? Roll number 115. Oh, no, 115, he will not answer.
No, ma'am.
105.
Ma'am, yes, ma'am. 115.
115, no answer. 114 will not answer. Okay, 84.
Yes, ma'am.
ఎన్ని చెప్పాను ఎన్ని ఫోర్ టైప్స్ లో ఏం చెప్పాను మీకు ఫోర్ టైప్స్ ఆఫ్ ఆక్సైడ్ ఫిలిమ్స్ ఏంటి నాన్న మనం తొందరగా చెప్పాలి అలా మెల్లిగా చెప్తే ఎలా ఏంటి ఫోర్ టైప్ ఆఫ్ ఆక్సైడ్ ఫిలిమ్స్ ఏంటి See, you are corroding yourself, kids. I'm telling you, if you learn like this, you'll be hurt if I say something. Okay, but then though all those who just praise you are not your friends. Sometimes your best friends are best critics because they'll get the best out of you. ఏంటి ఫోర్ టైప్ ఆఫ్ ఆక్సైడ్ ఫిల్మ్స్ ఎన్నిసార్లు మాట్లాడుకున్నాం మనం roll number 66.
Yes, ma'am.
Yeah, tell me what are the four types of oxide films?
Stable, non-porous, unstable, volatile, and porous and reactive.
That's it. So in which case the metals are passive?
Stable and non-porous.
Yes, good. Stable and non-porous, the metals are passive. Why? The oxide film is protective. Where the rate of corrosion is highest?
Volatile.
Volatile. Where the rate of corrosion is more?
Volatile.
More. Highest is dangerous is volatile. Where the corrosion does not stop or it continues uninterrupted?
Porous and reactive.
Yes, porous and reactive. Where there is no corrosion at all?
Unstable.
Unstable. Ante. ఇది ఎక్స్ప్లెయిన్ చేయడానికి why you kids don't do it. Why don't you explore yourself? You are corroding yourself, I'm telling you. If you think you can do it, you should do it. Okay. Next is solubility of corrosion products. So what you will you can guess from the solubility of corrosion products. If the corrosion products are soluble, the rate of corrosion is relatively less as compared to insoluble corrosion products. Why? Insoluble corrosion products will form deposits on the surface of the metal, leading to pitting type of corrosion, and hence the corrosion products. Okay, these are the points you should remember. Now take down one definition: passivity. What is passivity? Right. Passivity. Passivity. It is the property of a metal to suffer less corrosion, due to formation of stable non-porous oxide film. To suffer less corrosion due to formation of stable non-porous oxide film. Example: aluminium, nickel, chromium, tungsten, etc. Okay. Next. This is very easy. Nature of corroding environment. Okay. In that, what you would say? Temperature. What is your guess? Higher the temperature, higher is the rate of corrosion. So what you'll say? Temperature is directly proportional to the rate of corrosion. We'll write temperature is directly proportional to the rate of corrosion. So what's the first one? The nature of the corroding medium, temperature. Okay. And what you'll say? Temperature is directly proportional to the rate of corrosion. Why? Because higher the temperature, higher is the mobility of ions. Higher is the mobility of ions. And higher is the dissociation. And higher is the dissociation of metal ion. High is the dissociation of metal ion. Therefore, high corrosion. Therefore, high corrosion. So what's the keyword? Temperature is directly proportional to the rate of corrosion. Important. Very asked, commonly asked. Next. What is the second one? pH. What is the conclusion in pH? You'll say most of the metals suffer corrosion in acidic medium. Therefore, pH is low, more corrosion. pH is low, more corrosion. Or most of the metals corrode, in acidic medium. Okay. What do you say? Amphoteric metals like aluminium, zinc, etc. suffer more corrosion in basic medium than in acidic medium. Okay. Amphoteric metals suffer more corrosion in basic medium than acidic medium. Okay. But how about the pH? Less the pH, more corrosion. Okay, because most of the metals suffer corrosion in acidic medium with the evolution of hydrogen gas type of corrosion. That's a common thing if the SRP value is negative. Okay, it's an important one. But amphoteric metals will have less corrosion than in acidic medium than in basic medium, because amphoteric metals suffer more corrosion in the basic medium. Okay, I think I'll stop the session because you have another class. Good day to all of you. Answer your roll calls and you can start leaving the session. Okay, now answer your attendance. Roll number 61, 62,
Present, ma'am.
63,
Present, ma'am.
64,
Present, ma'am.
65,
Present, ma'am.
67,
66 present, ma'am.
67,
Present, ma'am. 67.
68,
Present, ma'am. 68.
69,
69 present, ma'am.
70,
70 present, ma'am.
71,
Present, ma'am.
72,
Present, ma'am. 72.
Present, madam. 73.
74,
Present, madam.
75, 76, 77, 78,
Present, ma'am.
79, 80,
Present, ma'am.
81,
Yes, ma'am.
82,
Present, ma'am.
83,
Present, ma'am.
84,
Present, ma'am. 84.
85,
Present, ma'am.
86, 87,
Present, ma'am.
88,
Present, ma'am.
89,
Present, ma'am.
90,
Yes, ma'am.
91, 92, 94,
93 present, ma'am.
94, 95,
Present, ma'am.
96,
Present, ma'am.
97, 98, 99, 99, 100,
Present, ma'am.
1,
Present, ma'am.
2,
Present, ma'am.
3.
Present, ma'am.
You joined just now. Why? Huh?
Signal problem. I have listened the class.
Did you listen to the class?
Yes, ma'am.
Which topic did I spoke at the last? What is the last topic I discussed? One not four. 104, 105, 6, 7,
Present, ma'am.
7 is present.
107 present, ma'am.
Okay,
Yes, ma'am.
8, 108 is absent. 109, 10,
Present, ma'am. 110.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15,
Ma'am, my laptop at the time internal mic is not working. It's connected to Bluetooth, and again I connected login with my mobile, ma'am.
ఎవరు నువ్వు రోల్ నంబరు
115, ma'am. It's connected to Nick band, ma'am. I didn't realize and started speaking out.
Okay. Any one topic? How does pH affects the corrosion? What are the 4 oxide films?
Stable,
16.
non-porous, unstable, volatile, porous, and reactive, ma'am.
Mhm. It
Your
comes
last
under
topic was
nature of
passivity, ma'am.
it comes under the nature of metal or nature of the corroding medium.
What, ma'am?
The answer which you gave me falls under which category? Nature of metal or nature of corroding medium?
Nature of metal oxides, ma'am.
Okay. Ante metals. Sarle. 16,
Yes, ma'am.
17,
Present, ma'am.
18,